Hi everyone, welcome to grade 3rd lesson 1 last part. In today's lesson we are going to discuss about comparing and rounding whole numbers. Let's get started. Comparison. We might in our daily lives always do compares, right? We compare how much, how long, how far, how tall, right? But what about large numbers, 6 digits or 7 digits? Do we really need the comparison of such large numbers? Let's find out. How about if you and your friend are living in Washington and New York, and you both start discussing and want to find out which state has a larger area? Well, you know they are big numbers, but you do not know how to compare. But we can easily find out once we learn the comparison. How about if you want to find out who is more richer? Is it Elon Musk or Mark Zuckerberg? Wow, their net worth is quite high. And so we'll have to compare them. Is it difficult? No. Really, once we learn how to do comparison, any big number can easily be compared. Let's start with our first method, vertical or column method. In this, I'll take an example, 89,764 compared with 89,385. We line up the numbers vertically. Then we'll start comparing digit from left to right. So we look at the digit at the highest place and we see that those numbers are same. So we move on to our 1000th place. We look at the digits at 1000th place and we see that those are same too. But when we move to our 100th place, we see the numbers are now different and 7 is greater than 3. But is it really 7 and 3? 700 is the top one and the below is the 300. 700 is greater than 300. So our top number has 700 while our bottom number has 300. Hence, now we can easily conclude that 89,764 is greater than 89,385. Let's look at another example. Now, if you look at this one, do you observe some difference between these? Let's look. We'll line up the numbers vertically. Now we can clearly see there is a difference. The top number has higher number of digits, while the below bottom number doesn't have a digit at its 100th place. But is it really does not have? It is actually 0. And we know 3 is greater than 0. What does it mean? That our top number has 300,000 more than our bottom number. So now we can easily conclude that 385,644 is greater than 49,835. Let's discuss another horizontal method. The vertical method is great, but when we are solving questions or word problems, writing down each number and lining them up will take some time. Hence, to be faster, we mostly use horizontal method. How do we do that? We start comparing digits from left to right of each number. We look at 3 and 3. They are same. So we go to the next digit. 8 and 7. Those are different. But we know 8 is greater than 7, which is actually 8,000 being greater than 7,000. Hence, we can conclude that 38,965 is greater than 37,390. Let's look at another example. How about if I say that each of these bulbs whichever bulb has a higher voltage will light up brighter. So can you guess which bulb will be lighting up? Let's look. Here on this bulb, we have number of digits as 5, while this bulb has number of digits as 4. So just looking at the number of digits, we can conclude that our left bulb will be brighter. So just going for revision of how we compare numbers, we first look at the number of digits. Is number of digits same? No, then in that case, number with more digits will become larger. But in case if they are same, then we'll start comparing each digit while moving from left to right. that is from higher place to the lowest place, like 100,000 to ones. But if digits are not same, then the number with higher digit will be greater. Let's solve few questions. In this number, we see that the number of digits are same. So which one will be higher? They are same. 9, 2. What do you see? 9 is greater than 2. So this number becomes greater. Let's go to the second question. Do you see anything? Yes, number of digits are different. This is 5. This has 4. Now we know that number of 5 digits are more, so this number is going to be more. How about this one? Do you see? They have exactly the same digits right now. So they become equal. That's how comparison works. Let's discuss our next topic. What is rounding off a number? Let's follow the conversation between two friends. Hi Ria. Hey Yami. Where were you yesterday? I went to Disneyland. It was very crowded. Oh really? How many people were there? Oh, around 50,000. Are you sure? Was that the exact number of people? Not exactly. Could be 47,825. I'm not sure. Ah, so you rounded the number of people. Yes, I told you the estimate number of people in the park, which makes sense. It's very difficult to find out exactly how many people were there in the Disneyland, right? But in so many cases, you would really don't need to find the exact number. A precise or an estimate is enough. And sometimes it's even very difficult, right? So that's what rounding is. It means making a number simpler, but keeping its value close to what it was. But how close? Let's look. If I say I have a number 3,473 and I want to just know the estimate on its thousands, I am not interested in the rest three digits. So I either want to know it is closer to 3,000 or whether it's closer to 4,000. If you look at this number line, you can easily see that here the number of hops are 4. While if I have to go 1, 2, 3, 4, 5, 6, right? So 6 hops. So we can say the closer is 3,000. What about if I want to know in terms of 10,000s? I have a number 72,375, right? Now, if I want to know 10,000, I want to know whether it is 70,000 or whether it is 80,000. I can see there are 2 hops. While to go from here all the way here, there are 1, 2, 3, 4, 5, 6, 7, 8. It's a long distance, right? So the closer is 70,000. But do you think we should draw a number line every time for each number? That's doable, but would take a lot of time if we are trying to solve our problems. So why do we need to round numbers to make it less precise? If you want to consider the case when you want to find the population. Say if you want to find what is the population of Alaska, isn't it easier and makes sense to remember it as 740,000 rather than exact number 740,133 people? What about finance in case of finance industry? If you want to discuss about school budget for 2025 to 2026, it's rather easier and to remember and easier to say it's 300,000 for this year. And same thing, it is also very easy to do calculations. If I give you a number, won't it be a little difficult to calculate? But if I say you calculate 3,000 plus 5,000, you'll easily say 8,000. So there are many cases when we need to make the estimates for very large numbers. So how do we round numbers? Number line, as we discussed, is one of the ways, but may take a lot of time. So let's discuss with an example of rounding to the nearest thousand. So first we go and find the target's digits place. So we want to go to thousands place. Ones, tens, hundreds, thousands. Now that we have found our digit, the next step is to keep the digits on the left as they are. So all the digits here stay as it is. So 1 and 2. The next step is that we look at this digit and we look and ask its best friend. You keep your best friends closer to you. So his best friends are 2 and 4. But whom should he consider? Always the right one, right? Because he is right. So we're going to go and ask his right best friend and say, are you greater than or equal to 5? See, he says, no way. I'm not greater. So fine. You say, I'll stay as I am. And you keep it what it was. And all the digits on the right of the target digit becomes 0. So 0, 0, and 0. Let's look at the example. The distance between Moon and Earth is 252,623 miles. When rounded to nearest 10,000, what will be the estimated distance between them? So let's solve to find the target digit. Ones, tens, hundreds, thousand, 10,000. The number on its left remains as it is, 2. For the digit 5, we look at its rightmost best friend. It is greater than or equal to 5? No. So we'll keep the digit as it is. And all the digits on its right becomes 0. So 250,000 miles. Let's revise how to round numbers. Remember, the key is to look at your right best friend. The first step is to find the target digits place, keep the digits on the left as they are, check if the rightmost digit is equal to 5 or more. If yes, increase the target digit by 1. If no, then keep the target digit as is. Change all the digits on the right to 0. Let's solve some examples. Nearest 100. Let's find the place. Ones, tens, hundreds. Keep the digits as they are on its left. So 587, and the digit for the target digit, we'll look at its right friend and we see that it is not greater than or equal to 5, so the digit stays as it is, and all the digits on its right becomes 0. Nearest 10,000. Let's find the target digit. Ones, tens, hundreds, thousand, 10,000. The digit on its left stays as it is. For the target digit, we look at the rightmost digit and see that it is equal to 5. So the digit will change. Let's increase it by 1, 37. And the rest of the digit becomes 0. The last question. Nearest 100,000. Let's find the target digit. Ones, tens, hundreds, thousand, 10,000, 100,000. There are no digits on its right. So we'll check the target digit. The rightmost digit is not greater than 5, so we'll keep it as it is. And all the digits on its right will become 0. But now that you know how to compare large numbers, do comment and let me know which state is larger. Is it Washington or New York? I would also like to encourage parents to consider these large numbers and bring up with the kids the scenarios where these large numbers can be compared and maybe estimated. I hope you have a good day. Bye bye and see you soon.